All right.
All right.
Yeah, we go in live.
Okay, that's a lot of us.
Yes.
All around.
That's great, actually. I think I'm enjoying
Yeah,
this.
I know that you like enjoying this. Put up the slides, please.
All right. Okay. Time to do some important stuff.
Yeah. So first of all, thank you very much for staying until the last session. You basically made it. This one is for fun. So you got through all the heavy stuff.
Yeah.
And now we're just going to have some fun with the hype of AI, obviously. We'll try to make it a little bit useful, at least. The idea behind this talk is to compare the two, I would say, leading AI frameworks in the Java world. And that's LangChain4j, which is a community project maintained by tons of different people from
around the world. Yes, exactly. And the Spring AI, which is a framework that is developed and maintained by folks from the Broadcom right now. And there's also a lot of community work. Rumor has it that there is somewhere in internet 3.5-hour version of this talk where we actually wipe code through this
the
presentation.
Entire demo. Yep.
So if you would be interested to find this, follow us on social media where we're going to be providing those resources where you can see how to wipe code.
So no vibe code today. We'll just show you how those frameworks compare. And we thought doing maybe a vote about which one is better, but then, you know, Josh is here, but also Liz is here, so we don't want to step on anyone's toes. So assume they're both great, excellent, and everybody are a winner.
But there's an idea. You don't have to do this, but if you're interested in kind of like participating actively, you can say that if you are like a Spring person, you can sit here.
If you like what you see more.
Exactly. If you kind of like, you're starting here, like you're not impressed, and after that you saw something interesting, you move to Spring side. Or you see something interesting, you can move to this side. So in this case, we can count at the end where we have more people, and this is how we can select the...
So you put the steps in. Yes, Arthur is voting LangChain4j. Yes. Liz is there with the baby. You know where to sit. Come on. So you get your steps in, you get some exercise. It's all fun. All right, we don't have 3 hours.
We don't have 3 hours here. We're just gonna go.
Who are those guys, basically? This is me with the hat, very easily recognizable. My name is Baruch Sadogursky. I'm head of developer relations in a company called TaxCare. We do awesome shirts. Let's start with that. That's like the important part. We also do kind of an insurance subscription for all your older versions of Java, Spring, and what's not, to make sure they are secure and you don't have any vulnerabilities. You know why it's important? Instead of doing that, you can actually do the fun stuff like vibe coding with LangChain4j. Jay Baruch over the internet and everywhere else, co-author of a couple of books related to DevOps and Java in particular. And this is my esteemed colleague.
My name is Rutger Gamov. I work as a principal developer advocate in a company called Confluent. Anyone heard about Confluent? I know that it's quite
like Jira for documents?
No, it's different. It's Confluent. Confluent, okay. It's a Kafka thing. Rumor has it that we have like a secret agreement between the Confluent and Confluence, so they will not do anything with Kafka, and we're not doing anything with Jira. So it works for us very well.
Not sure how it works for them, though.
Yeah, I don't know how it works for them. Yeah, I am maybe some of you picked up some of the books that I wrote about Kafka, and here and in the internet I'm GAUSSA.
So why are we talking to you about Java frameworks? Both Java champions and have a lot of Java expertise. Decades easily between two of us. We're speaking at conferences like this one, not like this one. This is not like any other, but other conferences. Obviously we consider ourselves leaders in AI integration with Java ecosystems.
If you're not the leader, you're already somewhere behind. So that's exactly how it's rolled.
All right.
Have you ever seen Java puzzlers back in the day?
Okay, dude.
Some people saw the original Java puzzlers, but who's seen the Java puzzlers?
The rebooted, the new generation.
New generation. Rumor has it there is videos on the internet. If you will go and look for Java puzzlers with me and Baruch, you can.
They are
find
mostly funny, but also a little bit educational.
Yes.
That's our style generally. All right. The most important slide of this presentation is show notes. You get access to all the presentation materials. You either go to my show notes, or which is speaking.j Baruch, or you go to Vic's show notes, which is exactly the same with copy, but basically same content under different URL. And for that, you go to speaking.gamov.io.
This is how the leaders in the AI space doing this. It's called engagement farming. So we need to boost our internet presence by.
You want to compare then who had more views?
Where?
On show notes?
No, we'll see. We'll compare after.
All right. Yeah. Conveniently, it's in the bottom of every slide, so you don't need to remember. You just can go there whenever. This is the talk that we do for now. Codepocalypse is now, and this is a lot of fun. In the show notes, you'll find the slides, the video, all the code references, GitHub repositories, with my private OpenAI key, by the way. Funny story, it's not easy to commit a private OpenAPI key to GitHub those days. I tried. First, GitHub told me you cannot, there is a secret in your commit, I will refuse it. And then I found a flag that I can actually override it and say, fuck it, I want to share. And when I did it, 12 seconds after, I got an email from OpenAI, we detected your key leaked to the internet, we are disabling it.
It's a good attempt to make excuse if something will break in your demo, you need to go and kind of fiddling this with, right? So that's what you were doing.
Nothing is broken in my demo.
Yes.
Okay, let's talk about LLMs. Who knows how LLM work? I don't. By the way, it was just an example. I really don't raise my head.
Who thinks LLM will replace you on your job?
No, Liz knows how LLMs work. This is why she's voting. Yes, I'm with her. All right, so basically how it works is there is an idea that everything text for LLMs is represented as vectors broken to tokens and then represented in vectors, which basically means while the network learned, it made an assumption that some tokens, some words are like others. Awesome is like red, and it's like red. Amazing red, and this is, and not only we know that they are alike, we can also assume how much alike are they. So awesome and nice are somewhere similar, but not really, because one is much stronger than the other. So they will be marked as similar, but not very close. There is also multi-dimension to those vectors. For example, basketball is related to a football ball because they're both balls, but basketball also related to a bat because they're both in basketball as a sport. But bat is not related to football. So imagine like a huge network, this is why it's network, of related terms with how they're related to each other and what is the difference between them. And then and that's semantic clustering, like happy and joyful are close to each other. And relationships is exactly what we spoke about, that happy is closer to joyful than automobile, although automobile is also somehow related to happy. You buy a nice automobile, you're happy.
Yes.
Or maybe
joyride, that comes from
and
joyful
ride. Exactly, all this stuff, right? And what happens next is just putting the next closest token that makes sense in this context because how they are related to an output.
What's the token?
That's what I said. It's in the simplest terms, it's a word. It's not really, but it's close enough. Right?
It's a representation of that will make sense in this space of many tokens. You can have a relations between not words but token. It can be sentence or it can be letter.
Yeah, but words is kind of good enough, right? And the nice thing about those vectors that once they exist, we can do math on words, which is pretty cool. If we will take king and subtract a man from it, we will have royalty as a concept, right? Because that's what it is. And then we will add women to it. What we will get?
Queen?
Not you. You saw the slides.
Okay.
What we will get? Queen. Thank you. We'll get queen with what certainty? Just draw a number. 50? No, 50 is terrible. Come on. 90? 95, right? So it's almost always works. Now the slogan almost always works is a very good representation of LLM networks and what we're trying to that. And this is a disclaimer that if something is broken in your demo, that's because it's only 95%.
Exactly, that's what I want to say. That's exactly how Story of My Life sounds like.
Almost always works?
Yes.
There is another joke that I'm really holding myself not to say.
I know. That's why I'm trying to push you to this like a dark places with the dark humor.
This is dark place. This is a dark place.
Nice.
Let's start working. So what we want to do is take you through a couple of concepts of how we work with LLMs in code.
Let me stop you for a second. Just for a second. I will remind you, every time when you hear someone say like, LLM will replace me, LLM is dumb. It knows how to find things very fast. The things what Baruch just said, but interesting use cases, if we will augment this, and we're going to be doing this, is some of the things that Baruch we're going to be talking right now, allows us to make them a little bit more smarter and doing things that we need them to do. Not what they will tell us to do, but another way around.
Yeah, that's a good disclaimer. So what we want to do, we want to use LLM in our application. How are we going to do it? We're going to embed the usage using either LangChain4j or Spring AI. We'll start with LangChain4j.
Yeah.
So what I want to build here is an airline royalty service. I mean, we live on a plane, so that's kind of important to know what we can get if we fly a lot. So that was the example that we chose. Funny enough, after we chose this example, apparently the example of LangChain4j with Quarkus is also the same idea, probably for the same reasons, not a copy-paste. Okay, so what we do here, this is my service, and it's as simple as it can get, right? I just create a model, and here we go. And I will use OpenAPI. I will use OpenAI, a builder. I provide an API key, the one that got blocked. And then I use some model. This is an ancient one, but who cares?
But it's cheaper. And it also serves a lot of purposes for our demo.
Temperature 0.7. Now, what is this temperature thing? This temperature thing is the level of freedom we give to our LLM to guess at the distance of our vector, right? What are the chances that instead of queen in our equation, it will output maybe princess
or duchess?
Or duchess.
Since we...
of course,
in the Netherlands.
Yes, or something like that. Now, why it cannot be very high or very low? If it is very low, then let's put it 0. If we put it 0, the LLM won't guess anything, because the only word that is similar to king will be
king.
And then obviously nothing works. If we do it 1, which is like the maximum range, it will hallucinate like it is on drugs, more than usual. So one of the tricks of getting the right answers from LLM, which are creative enough, but some resemble something in the real life, is playing with this temperature. And 0.7 is number, we don't really care again for this example, and this is how I connected OpenAI to my Java application. This can be done inside any code that you have inside any setup that you have for whatever reason you have. You can just plug in usage of OpenAI in one line of code. Basically, I can be nasty and make a very long builder in one line of code. Once we have that, once we created the model, we just take the query from the user. We have some system prompt, obviously, here. You are an expert in airline loyalty program assistant, whatever, and then we send it to the chat. And we say, hey, chat with me. This is the message. Give me the result. I get the result back, and I send the result to
the more I look at this code, the more I think that Dr. Venkat would be upset. He doesn't like to use like curly braces, a lot of like you see, like you have a lot of curly braces. Like if you scroll down, this is nice, like when you have a builder, this is nice, right? But the curly braces, you want to see some cool stuff?
Wait a second, let's see if it works. Don't you want to see if it works? Let's see if it works.
Probably
no,
works
but
how on. You said this most of the time?
95%.
95%.
Yeah, all right, let's see. It actually looks like it might work. This is how it looks like. I didn't do the UI. I vibe coded the UI, but it's okay. All right, ask me everything about airline loyalty programs. How do I get status on Delta? It doesn't matter. Let's just see that it works. Maybe. Here we go. Right, we have some details on, and this is very small, and you're not telling me. We get some answers about how to achieve elite status, blah, blah, blah. It works.
Sounds good.
One line of code. Well, 5 lines of code.
Yes.
So that you don't like. Code that you don't like.
I mean, like the best code that is code that you never write. And this is how you do with the language that all the kids love because we hate as a parents, and they will love this when they will grow up. It's a YAML. It's a Spring. This is nice. We just put this OpenAI configuration, put the key here, we select the model, and inside my code, inside my, say, my configuration that will connect to OpenAI, I'm specifying prompt here, and inside my controller that I will be exposing through UI, I'm just sending this message to process message, things like that. And this is my version. We developed those applications not looking to each other. We just decided we will have some common concepts that we're going to be exposing today, and Baruch will talk about this in a few seconds. So that's why UI would be cooler, but look at this. Like my UI, I think, would be even cooler because look at this. Plane is actually flying. Whee! Anyway, so say I am Sarah. What's my luggage allowance? See, thinking. It's the beauty of vibe coding. So it gives me some generic information based on the information that the model knew during the time when the model was trained. There was like some models, they have this cutoff date, so they don't know much about the current state of the world. They know something that happened before some time of the year. But also interesting thing is like if I would ask this conversation.
Wait, don't. First of all, now we saw your code, we saw my code, and people go like, your code is all
and
like...
everyone is going over there immediately because I use YAML.
And then I say, stop it. Don't move. Because he cheated. He not only used a library for LLM, which is Spring AI, he used it integrated into this amazing framework called Spring Boot.
Exactly.
That does...
See me. That's what I'm going to be doing all days.
That does dependency injection, annotation processing, declarative code, and all this beauty.
Profiles.
But if I take the lone and verbose framework, which is LangChain4j, and put it in a context of a framework as powerful as Spring Boot, called Quarkus, suddenly I get all those goodies that he has from Spring in LangChain4j as well. Look at that.
Yes.
Look at that.
Yes.
How about this code?
Annotations. We love the annotation. Who loves annotations?
Annotations is any day better than YAML.
100%. Annotations is great.
All right, so look at that. Now system message is an annotation. Register AI service, that's our dependency injection. And then all I need to do is say, user message is a question that comes from like some UI.
Yeah.
And this is all.
Yes.
How about that for Venkat?
This is actually pretty cool. Even though like I didn't use this multi-line, but I appreciate how you use multi-line strings in the modern Java features.
It's all intelligent.
I use this only for SQL. Like every time when I need to like write the
but
SQL
it's
code.
Perfect for prompt.
Exactly.
It's perfect.
One of the things that we wanted to say, but we didn't say about this. You usually not programming in the raw framework. So that's why everything that would be working or not working will be in the context Spring AI plus Spring Boot and LangChain4j plus Quarkus.
Exactly.
And this is actually a good thing. It's not a bad thing because there's some other things how these frameworks and libraries can benefit from.
Okay, you wanted to say something about Sarah.
Yes. So another point that I tried to make when I was talking about LLMs, and I always say like they dumb, because I would expect that it will pick up, because in the very beginning I introduced myself. I said, yes. Sarah, like, do you know who? Oh, that's better. How about this? Say
my name.
Name.
Definitely.
So, and the response was kind of like, okay, so...
I have no idea what you're talking about.
If you would like to provide your name, I can address you more personally.
You want to try it? Okay. I think you were Sarah.
It doesn't matter. At this point, it doesn't matter.
Okay, it knows you.
And now it should work.
Yeah, now say my name should work, because it promised.
Yeah, yeah.
Okay, I have bad news for you, it lied. Now, obviously, there is a very good explanation to that. If you remember how it works, we have the chat service, we send exactly one message in, we get response, we send it back to the UI.
We also wrap this message in this prompt thing.
But it's still a single message.
Yes.
It is completely stateless. We didn't remember Sarah or Heisenberg anywhere. Now, obviously, that would be an important feature to add. So let's add it.
Yeah, and I think that's a good time if you have a slide for this. You usually do have a slide where we're going to be talking specifics, what we're going to be showing to you today, and why this is important for certain use cases that you will be implementing with those frameworks. There's no questions that you will be implementing some sort of like AI integration system in the next year, because this is where the businesses are going. Liking this or not, this presentation will give you a roadmap.
Yeah, we don't have 3 hours.
I understand.
Yeah,
I remember.
Go for it.
So first of all, we're talking about this the system prompt that will create this initial context for LLM. And this context window will define how much data we can push through the request. It would be extremely wasteful for the companies like OpenAI or Anthropic who manage and host those publicly available LLMs to maintain state of every conversation. So that's
for every user.
Exactly. So that's why they come up with like a cool tools called ChatGPT and Claude Desktop that allow you to kind of store your information locally, and it will appear like everything they remember everything about you.
But what it actually does is what we showed. Like it's send it there, one phrase, it gets one phrase or more back.
Yes.
There is no state. Yeah. Someone has to maintain it.
Yeah. So that's why every time when they see this crazy tech talk, when the people try to convince you that they know so much about us, they usually don't, because they don't care. It's too expensive to maintain this. Now, how we can maintain this? So we need to, our framework should be able for us give ability to maintain this state. Because we writing app can have a state. So we will be able to capture this information about previous messages, so we can have a meaningful conversation. And this context window will be constantly enriched with the new data or the updated data, and how LLM would be using it. God knows how, because sometimes we see when the context is growing, we can get some stuff. Yes, and this is where we're going to be showing how the framework will be memorize some of the bits of this thing.
And the storage is pluggable. We will do the most naive in-memory implementation, obviously, because that's a demo in a conference, and there is 95% anyway. But of course, you can plug in any storage, any database, wherever you want to keep this conversation. It's all completely pluggable. When you're ready.
Now, so what I just did, I just switched to version that will include a little bit more.
What do you mean switch? You just wrote it.
Yeah, I just wrote it. I just wipe coded this. I will use this a little bit, so we will not have any. Yes. We're gonna do switch to my log, and.
Come on, this is how you do it?
Yep.
I just write code when you're talking.
Yes. Check out.
He's cheating.
I revealed all my secrets.
He's cheating.
Yeah, never. The best improvisation is well-prepared improvisation.
He's cheating.
So remember this initial system, the message that we will configure our chat client. We have a default system prompt that will be sent with every message. And now we're adding these very cool components that Spring AI would be used all over the place when we need to deal with augmenting our conversation between LLM and our application. It's called advisors. And one of the advisors, there's a plenty of things that you can implement yourself, or there's plenty of things that allow you to start quicker. So in this particular case, message chat memory advisor. So in this particular case, it will be using this memory advisor that's implemented from the interface from Spring AI. And in my particular case, chat memory, where's my chat memory? Would be injected from somewhere else. From my config, that's my config. And here I stored this inside some sort of like a hash map or whatever it will be using internally. We will use in-memory chat repository by default. If you will be running this in production, you want to use something more scalable that allows you to maintain maybe even files. It's also fine. Now we have 50 messages that we're going to store it. So let's continue this conversation. Hi, I am Heisenberg. Hey, I can assist you. Okay, say my name. Oh, what's happening? Hello.
Spring.
My name is. Maybe it doesn't know. Now I can say my name.
Yeah, no, you're just not very good at that. Just admit it. It's fine. Happens to the best of us.
Let's see. Let me refresh it. Let's run.
Yeah.
And
let me know when you give up.
Yep. The cache invalidation is the. You got them right.
All right.
Yes.
Okay. So you saw the code. Let's see the other code. And the other code is, again, extremely simple. I show you the Java code without the simplifications of Quarkus.
Yes.
So you will see the idea behind it. All right. There is an object chat memory, and that's we create. There is a builder for message window chat memory. We provide how many users, how many messages you want to store. You get 50.
So, is it Kotlin?
Yes, it is, of course.
I just realized how many Scala developers we have in the room. So the thing is with the Kotlin, if you're a very seasoned Java developer, you can easily read the code. But the different things with the Scala developers, they not even read code that they own.
How we got to Scala?
I just noticed that you use Kotlin here, and I cannot stop.
But the thing is, you didn't notice, and almost no one in the crowd noticed, because it looks like Java.
It's a great language.
Yeah, all right. So chat memory we created from message window chat memory with max memories of 20, and then we just use it exactly as you would use it. If it's a new message, add the system prompt that we had. We want to start the conversation with the system prompt. If we already have messages, then just add more messages, right? It's as easy as that. Once we added those messages, they will be sent with every new message that I send. Now, this is exactly how it works in your ChatGPT or Claude Desktop. Every new message you send and every reply you get will get sent every time. Remember context window? This is where it gets bigger and bigger and bigger and bigger and bigger until the prompt is so huge that it doesn't make sense to LLM. And in good applications, we will get a message, hey, it looks like you've blown up the context window, you probably should start a new conversation, right? And in those that are not very good, it will just return some kind of bullshit. So this is why we limit the messages, and you saw it, I limited to 20, Victor limited to 50. This is more or less what makes sense. Right, and then if we blow up the context window, we will send a message that we blew it up. And basically...
Just a quick one here, like very much the same style of API, but again, it's a builder. We have a system prompt, and we have ability to have different conversations based on certain like user ID and things like that, or new session of the browser will have its own memory.
Exactly, right. Okay, and just to double check that it works, because obviously, hi, my name is Bob. Bob. Yeah, hello, Bob. And then we can ask, what's my name? And it will tell me that my name is Bob. And can we please get to the business already, basically,
yes.
Right? Okay. All right, so that was conversational memory, pretty cool.
Now, it's not very interesting, right, to remember someone else's name. We want to build enterprise applications.
I'll do RAG, you write code.
Okay.
Okay, so retrieval-augmented generation is the ability to add to our prompt stuff that the model doesn't know. What the model knows is what it learned during the learning period. By the time this model is released, it starts to lose relevance. Today, it will tell you, hey, my cutoff date is whatever, December 2024. I don't know anything past that. So what do? We get the information that we wanted to know and send it with our prompt. So we can ask, what is the latest version of Spring or LangChain4j? And it will tell you the latest version is 1.0 beta 1. Now this is an outdated information. The LangChain4j already been released, it's now in version 1.01, so it's outdated. How can we make the LLM know what's the newer version? We can, for example, point to a website where the information about the releases is. Our framework is going to download the information from the website, including what I'm looking for, the latest version. We'll send it with my question, what is the latest version, to LLM. LLM will say, well, the answer is right there, and will return the correct answer back to us. This is exactly how it works. Very stupid if you ask me, but that's it. User query, system receives the question, what is the latest version of LangChain4j? Vector search, it will search in the information we provided with the prompt, which is the content of the website for LangChain4j. And then it will retrieve what it already knows from the model, plus what it learned from what we just gave it, do some kind of conflict resolution, and retrieve and get us the response, which will be the right response.
Yeah, so the vector search is not really nothing to do with like AI and Gen AI. It's just approach how you can find similar items in the space of unstructured data, for example, instead of doing kind of search by every symbol.
Yeah, we already explained that.
Yeah.
This is exactly the same thing. What we're going to do with the content of LangChain4j website, we are going to build tokens out of it, calculate nearby vectors similarity, and then send this part with our prompt to the network. The network will search in its own, plus what we gave it, and will return us a reply, which is a combination of both or conflict resolution of both.
Yes.
You ready to go?
Yes.
Go for it.
So for my particular case, I decided to update my information for my loyalty program from the websites of airlines. So I have a fresh information, and I want to make sure that this LLM will not gonna hallucinate on some outdated data. So if I would say something like this, like a very specific question. So what's the amount of PQPs and the PQFs needed to achieve each tier in Premier Stats in 2025? I'm pretty sure the model was not trained in 2025, or like the data set was cut off before that. So let's see if this will be able to solve it. And now it actually gives me exact, precisely information because I created a local database that will include my local vector database. Spring AI supports majority of existing implementation of vector databases. If you go to start.spring.ai, you can find multiple different modules and starters for different databases. In my particular case, just use simple implementation in memory implementation. And also, I vibe coded this quick search, the way how will actual vector search will do the thing. So I can go say here and put the same query here, and it will found a bunch of documents that include this information. So those chunks would be extracted from the vector database, and like Baruch says, will be sent together with my request. So in this particular case, I'm enhancing my system config, and together with this, I also need to, where's my controller? Yes, this controller. So now it's also included this assistant service, and it also will include inside where's my process message, where I'm extracting this from my knowledge base service. My knowledge base service is just a in-memory implementation of this, and files that are stored inside this were scrapped from airline's website. I could do this also online, but it will require some sophisticated kind of like ways how I can pretend that I'm a real user, not a web scraper and things like that, because airlines are pretty, touchy about those things. So essentially, what we have here now, we have I am Sarah, and what's the? Let's see if I have this already somewhere. Yeah, I'm Sarah. What's my luggage allowance? It will give some generic information, but this generic information is up-to-date information. You want to show something?
Yep, I want to show pretty much the same. Yep. So same idea. We can ask a very specific information and get hopefully a very specific answer that the generic model obviously didn't know, because it takes it from some information that we provide. How do we do that? We use, again, a built-in feature, two built-in features for LangChain4j. The first is the ability to parse content to tokens. Any type of content. It could be string that we give here. It could be, we can load files, PDF files, markdown files, whatever. Or LangChain4j can go to a URL for us, get the information from this website, and then parse it to tokens. Right, so exactly the same resources. This is where the information comes from. Obviously, we get banned from accessing United directly. We have a fallback, which is string of the same content, so you will believe that it works. And then what we do is we just say URL document loader, load. The information is loaded as tokens, and then the information is just loaded, and then when we say split, will split the content to tokens, and then ingress will actually ingress those tokens into a vector database. Now, which vector database? Whichever you like. LangChain4j connects to all of them, and we use in-memory vector database because stupid demo.
I want to point out one thing very quickly. You can find the list of this in in documentations, the easiest way to find it in Spring Start.io. I wanted to also point out one interesting use case very quickly, and we can jump to another quiz because we have running some time. So now, remember, we want to have like some sort of like a little bit personal approach. So that's why we're introducing ourselves, and I don't want to type every time that I'm, kind of like a 1K big shot.
I
want to
think
do something.
we have more important stuff to show.
Yeah, just one quickly. And now it's supposed to be saying, hey, do you recognize me? What's my status? Let's see if it will pick up. Nope, I don't have any personal information access. So in this case, I can implement another advisor that will augment this with data that stores not in vector database, but in the real database. So in this case, information about the users will be stored inside this table, and that's kind of some of the data that we're going to be used next.
All right. Okay. We need to move on. Next thing that I want to show you is unrelated to Spring AI or LangChain4j, but it's very related to both of them and generally any AI development, and that's the Docker model runner. Since very recently, like a month ago, Docker released a feature that allows to store and run models locally with the same ease as they were Docker images. They use the OCI format, so you can store them in your local Docker registry, or you can pull them from Docker Hub. And it has exactly the same content, the same concepts. You can pull a model, you can list the models, you can run a model, you can delete a model. Everything that you know about Docker suddenly applies to local models, which is pretty cool. Now, one of the coolest things here is that Docker Desktop uses GPU on Mac, on your development machine, for running those models, which is very unusual for Mac architectures and also very cool. Now, you can do stuff like just run it and say, hi, I am Bob. It obviously there is no memory connected, so it won't remember. But you can run this model for debug purposes, which is pretty cool. Now, as long as my engine is running, I can set up here in the settings that all my models will be, where is it? Not here, not in Docker Engine, maybe in Advanced. Where was it? Sorry.
Which one? You need to enable this inside.
Yeah, no, it is. Features. It is. That's what I'm looking for. Enable Docker AI. Here. Yeah. Thank you. Yeah, this. Right. As long as my Docker desktop is running, all the local models are exposed to the host side, to my computer, through a simple HTTP. It means that I can do anything with them, including, obviously, connecting to them in my application.
How you configure your application? Let's move on. Let's quicker.
I need to type it. You ready?
Okay. Yes.
Switch and go for it. I'm going to type it.
So, and I already done. Like my application now runs against my local model that will be Ollama. I'm using slightly different approach. Baruch uses this model runner from Docker. I use the native application called Ollama that runs this model locally. So I can do something like run Ollama, and I also can type things here.
You can type things?
Yeah, like hello.
Jesus.
My name is Bob. And now my application actually works against, let me refresh it. Now it uses Ollama, it uses Mistral, and saying, hi, I'm Sarah. Let's do this, allowance. Same thing. Now, in this case, it uses local data for RAG, it uses local data from database, and it also uses local model to converse with. The answer would be a little bit either slower or it would be a little bit dumber. 100% it would be dumber. But you see, it knows a few things.
But not really.
Not really.
Yeah. I'm ready. Okay, here we go. Kudos to Liz. This is copy-paste from her blog post about how to connect LangChain4j to a local model that runs in Docker desktop. Basically, this is one line of code, right? It's a builder. API key is not needed. That's my local model. Localhost, that's the port that you saw in Docker desktop. And then I connect to the Llama CPP that runs inside, and the model name that I'm using is AI Mistral, which is again the model name from Docker Hub. That's exactly how I downloaded it. That's it. Now, obviously, this is Java code. You can do whatever you like. You can have multiple builders for different models. You can load more than one model at a time and ask questions of different models because some models are better than others for different things.
Yes.
And then you can combine the context in your application and send the reply that you got from one model to completely another model and get a bunch of interesting and exciting stuff. This is very cool.
Just quickly. Sometimes when we're talking about the things, it's not about what answer they can get, but we also want to force them to do something.
Yes.
For that, both frameworks, they have support for the concept of tools. So in this particular case, I will show you how it's done in Spring AI. I swapped back to my ChatGPT because it's faster. And I say, can you put the calendar, because it's a chat bot that helps me to manage my travel, calendar invite in my calendar. And after that, it will recognize that the request for this particular case sounds like a request for doing something that model doesn't know, but it will return response to actual client. So the actual client pick up the tool, and I can say that I'll just copy here as is, see if it will works. Let's do this, and it's just like
we don't have time.
Yes, and just do this inside my console. I'll see the tool was called for this. I supposed to be, once you provide the details, I can add event to calendar. So it was not able to recognize the input.
Yeah, no, but I got the idea. The idea is that sometimes in your code you want LLM to defer to a tool.
Yes.
Right? And this tool can be...
Send email, send SMS, right?
And this tool can be something that is written in your code, because remember, your Java code you just write the code.
Yes.
Or you can use a reusable chunks of programs dedicated to cross-LLM configuration called Model Context Protocol. We have no time to go over demo, but Liz just today showed an amazing demo she did an amazing talk about
Model Context Protocol, how to use it, and the examples.
And LangChain4j,
exactly.
right. So this talk was recorded. Don't forget to watch it, and in our show notes we will reference to it once it is published. What is Model Context Protocol?
Model Context Protocol is the way how you can tell LLM, standard way to tell LLM how to integrate with external tools.
Yes.
So this server will expose a little bit information about itself, like saying, hey, I have a collection of the things I can do for you. And there's a special magic words that the model can return to client application, the
like
MCP server client.
Yep.
So for example, you're saying there's a GitHub, the Model Context Protocol server, can create a pull request. So when you have this information in your prompt,
people are leaving. We're losing them.
People are leaving and we're losing them.
All right. Okay. Everybody watch Liz talk. We're out of time. You want to do this?
Which one? This one?
Yes, yours. Yes. Thank you very much. The most important stuff is the show notes. You go to speaking.jbaruch or speaking.gamov.io for everything you want to get about this talk.
Examples, videos, slides, some of the resources if you want to learn something more, something curated resources,
yes.
If you will, because we're leaders in the
AI
industry,
space.
we need to create this curated list of
and
things.
With that, thank you very much.
As always, have a nice day.
We are not going anywhere. If you're not going anywhere, we can do Q&A until tomorrow.
Yeah.
So if anyone has any questions, go for it.
As always, we're available for enhanced interrogation.
Yes.
With extreme prejudice.
Yes. Yeah, no, people just want to go.
Okay.
I don't know what it means, but people just want to go.